In this example, we'll sketch the graph of the polynomial p of x equals 3x cubed plus 2x squared minus 7x plus 2. To sketch this graph, we need to find the y-intercept, the x-intercept, and the end behavior of the graph. For the y-intercept, we need to look when x is 0. And if x is 0, our polynomial is 3 times 0 cubed plus 2 times 0 squared minus 7 times 0 plus 2, which is just 2. So we get that the y-intercept is the point 0, 2, which we can place on our graph. For the x-intercept, we look when y is 0. This gives the equation 0 equals 3x cubed plus 2x squared minus 7x plus 2. To solve this, we need to use the rational root theorem. If you'd like to see the steps of this done out, click the link now. Using the rational root theorem, we find that our roots are -2, 1/3, and 1. So the x-intercepts are the points -2, 0, 1/3, 0, and 1, 0. And finally, for our end behavior, we need to see what's happening as x goes to plus and minus infinity. Recall, for large values of x, a polynomial acts like its lead term, which in this problem is 3x cubed. Now for x going to infinity, 3 is positive and x cubed is positive, so 3x cubed is positive, meaning that our polynomial is also going to infinity. And if x is going to negative infinity, then 3 is positive, but x cubed is negative, since x is negative. So 3x cubed is a positive times a negative, which is negative as well, which means our polynomial is going to negative infinity. Now the only thing left to figure out is what happens between the x-intercepts. Remember, the graph can't cross the x-axis between the intercepts, because if it did, we would have another x-intercept, but we found all three of them. Which means between the two x-intercepts at -2 and 1/3, our graph is always positive since it has to go through the y-intercept 0, 2. What about between our other two x-intercepts, 1/3 and 1? Here again, we know our polynomial is always positive or always negative because it can't cross through 0 without having another x-intercept. So which is it? Is it always positive or is it always negative? To find out, we need to check the value of p of x for an x value between 1/3 and 1. Let's take a half, or 0.5. In computing it, we get that our polynomial at 0.5 is -0.625. which for us is most important because it's negative. It means that our polynomial is always negative between 1/3 and 1. So we now have a great sketch of our polynomial using the x-intercepts, the y-intercepts, the end behavior, and that our graph can't cross the x-axis between the intercepts.